Hello guys and welcome. In this lecture we'll see how to use thresholding in OpenCV. So first I need to create a Python file. I will call it thresholding.py. I will import CV2 and numpy. Then I will read an image from here, cv2.imread. I will read an image in the data folder. I call it gradient.png. You will find it in this data folder. So this image should be a grayscale image. For that I can use CVT to convert the color, so CVT color, or I can put here 0 and it will be loaded as a grayscale image. So if I show this image with cv2.imShow, I will give it original as name of this window and call the image, and then using cv2.waitKey 0. Let's run this code to see the image, thresholding.py, and here is the image. To do the thresholding we can use OpenCV threshold, so cv2.threshold will give it this image and then the thresh value, so we'll give it a thresh value and a max value. If the image or the pixel value is less than the thresh that we will give, it will be set to 0, otherwise it will be set to that max value that we will provide. So I will give it 127 as thresh and max value as 255, and I will give it also a type of thresholding, so cv2.thresh, and there are many types of thresholding. If I, for example, use a binary thresholding, it will, if the pixel value is less than 127, it will set it as 0, otherwise it will set it as 255. So this method will return value. We want to use iterate, and the thresholded image, let me call it thresh1, and this is an image that we will show here. So cv2.imShow, this is binary, and call the thresh1. So let's see this image. So now as you can see, all the values less than 127 are set to 0, means black, and otherwise it will be set to 255 as you can see, and it is white. There are many types of thresholding, so if I take this one and see the other type of thresholding, so for example there is thresh binary inverse, so this is just the inverse of this one, means the less than 127 will be white and the others will be black. So I will call it here 2, and this one as 3, and this one as 4, and I will change here the type of the thresholding. So let me see thresh trunc, for example, and other type of thresh also, like thresh, for example, if I use tozero, for example, and we should come here also and put this, show this image from here, cv2.imShow binary inverse, and it is here in the thresh2, and the same also here for the binary trunc or thresh trunc, and come here and say thresh 3 and also thresh 4 and convert it and saying to 0. Let me show them here, and here as you can see this is 0, and this type of thresholding here is trunc, and this is the inverse of binary, So this one is binary, this one are white, and this one here, so it's just the inverse of this image. We can also combine two types of this binary, so I can add another type of binary here, like for example cv2.trash, for example trunc, and show them like that. So as you can see, this is the trunc, this is binary inverse, and this is the binary plus threshold trunc. We can do it in any image. For example, if I read the Sudoku image and apply this on it, so as you can see, this is tozero, this is the trunc, binary inverse, and this is the binary plus trunc. You can see that we have chosen here some random numbers, so I chosen 127 as threshold and the max value as 255. You can choose any number in the range of 0 to 255. Of course, the threshold should be less than the max value, but this method, as you can see, it's resulted in very bad images, and they changed the images, and we are not able to use them for many other tasks or many other things, like for example edge detection or contour detections. So for that, OpenCV provides us with another function that permits us to, or that permits OpenCV to choose a number that represent, for example, the mean of some pixels. So for a pixel, it will look at its neighborhood and calculate or compute the mean of that neighborhood and use it as a threshold for this specific value or this specific pixel. So let's see this function and see how it is working. I will comment these three ones, I don't need them, and I will keep the last one. I will also delete this second thresholding, and I will also comment these ones. So I will call the resulted function as thresh1. I will call it thresh1 just, and cv2.adaptive threshold, and I will give it the image, the max value, like this one here, 255. You can of course give any number, and the adaptive method. So cv2 provide two types of adaptive methods. We will see them here. So adaptive threshold mean C and adaptive threshold Gaussian C. We will see both of them. So now this one, and then adaptive or the threshold type, I will use the same like this one, the binary thresholding. Let me write this here, and also it will take the neighborhood size or the block size. I will give it as 11. You can give it as 11 or 9 or 7 or 15, something like that. And also the C value, which will be subtracted from this mean. So this is the first type of thresholding, and the second one is cv2.adaptive threshold. I will give it also the image and the max value, the same max value, and at this time I will give it as adaptive threshold Gaussian C, and I will use the same ones like this one. So now let's see these values here, cv2.imshow, or see these methods, how they changed the image. The first one is adaptive mean, and it is thresh1, and the second one is like that, adaptive Gaussian, and it is this image. So now let's see these images. So this is the Gaussian, This is the mean, and this is the normal thresholding, binary thresholding, and this is the original image. So you can see from this adaptive thresholding that the images now is better and better than this type of thresholding, and can be used for other topics that we will see later, like the edge detection and the contours detection, for example. Another type of thresholding that I want to mention here is the otsu binarization, which determines the thresh value from the image histogram. So this type of I will just copy this one and see the otsu binarization from it. So I will come here and see here thresh without a number, so I will add it here as cv2.thresh otsu from here, and I will give this as 0 because it's just it won't use it. It will calculate or determine the threshold from the image histogram, but this 0 is for this threshold binary. So if I come here and show this image, cv2.imshow otsu, and show it here like that, thresh, and then we can see this adaptive Gaussian, this adaptive mean, and this is the otsu, and here you can see the difference between it and the binary here. So of course it isn't what we want to see, but it's better than this one, and it can be useful for another type of images, and it can help in that case, especially when we do more operations on the original image, like for example blurring the image or doing some smoothing operations on the image. In that case, the otsu binarization can be helpful. We'll see it later when we take these methods and apply. We need to apply threshold on the images for example edge detection and contour detection.